Hello and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. With this video we've formally entered the second half of the book. And so we're going to start talking about object orientation. Now in some ways this might seem a little bit weird because, as I've said from the very beginning, we have been playing with objects a lot in Scala. Every value in Scala is an object, and we can reiterate what it means for something to be an object. An object is something that has data and functionality associated with it. So, and we say that it encapsulates those two elements. So for example, when we start up Scala, if I just make a variable, call it A, there are methods on A that I can call. And normally we call them with the dot notation, though as we've seen we don't have to. In fact, actually more generally, with tab you can see quite a few of the options that we have here. So A is an object. It has a value associated with it, has information associated with the number 5. And it also has a number of different methods that you can call on it to do things. There are things like strings were also objects because they had the information of the value that was stored there, as well as the operations you could perform on them. Okay, so we've been playing with objects this whole time, which makes it almost seem kind of weird to say that now we're going to start talking about object orientation. While we've been playing with objects the whole time, we really haven't been setting up our own new types. We have been using objects constructed in ways that other people had set up for us. And the one exception to this was we did kind of build our own type of grouping data when we made case classes. And so in some ways we're going to kind of continue along that line because what we want to do now is we want to build regular classes. So Scala is a class-based object-oriented language. And it turns out that since object orientation, its most general definition, just means that you have objects, and objects are just data and functionality grouped together into a single entity, there are actually lots of ways to come about this. Not all of them are class-based. Scala is, Java is, C++ is. I would say most of the languages most of the object-oriented languages that you use are class-based, but one of the most commonly used languages right now is JavaScript because it's used so broadly for programming web browsers. And JavaScript is, while it's object-oriented, is not a class-based object-oriented language. So what does it mean to be a class-based object-oriented language? Well, it means that we define our objects not by, in some sense, writing objects, though we'll actually learn in Scala we can write code that represents a single object. But most of the time, we write the code inside of something called a class. And the class forms a blueprint for the objects that we want to build from it. So let's remind ourselves of what we've seen with case classes before. So let's build a little case class for a rational number. A numerator, which is an int, and a denominator, which is an int. And for a case class, we would have just stopped here. Okay? And this would define a type for me, and so I could do something like make the fraction 2/3. Okay? A case class is a special form of class. We'll come back to this later after you have a better grasp for what exactly happens in classes, and we'll start talking about what it is that putting this keyword case here is doing. Turns out basically this is just syntactic sugar. It adds some extra stuff to the class for us to make it so that we don't have to do it on our own. But we want to look at how we define just classes in a more general sense. And so I actually want to redefine this rational, not as a case class, but just as a normal class. And I want to show you what that looks like and what some of the implications are. So notice that I start off and it looks just like what we did with our case class, but I'm going to do one extra thing. And technically what I'm about to do is something that was possible with case classes, but it was a complexity that we avoided earlier. And that is that I'm going to put a body on here. So I'm going to put some curly braces, and then I'm going to put a block of code. And everything that goes inside of this code is associated with this class. And this really shouldn't seem too odd to you. This is just a declaration. So we've seen previously, we've had declarations of variables where we used either val or var as the keyword, and then that was followed by a name, and then we gave it a value. When we were writing functions, we had a keyword called def, and we gave it def, and then the name that we wanted it to use, and then we had parentheses and an argument list for it, and then we could say what it was equal to. For classes, we start off very similar, except now instead of being val or var or def, the keyword is class. So class is a new keyword for us in Scala that is used for declarations of classes. We follow that with the name, and typically we use an uppercase first letter for naming our classes, and then we give a set of parentheses and an argument list. This is optional if you don't want to pass anything in, but it turns out that most time in Scala you should be building your classes so that they take in values that initialize the things. And then we have curly braces, and whatever we put inside of this curly braces is kind of the contents of this class. So what would go inside of here? Well, the things that would go inside of here would be things like the maybe additional information that we wanted, stuff that wasn't passed in, or the methods. So when we did our case class previously, we didn't actually add any of our own methods. Okay? But there are things that are nice to be able to do with a rational number. It's nice to be able to take a rational number and add two rationals, or simplify the rational, or whatever else, or multiply. Maybe I'll start with that one because it's one of the easiest. So now I'm going to start off by writing a method called multiply. Notice that I'm writing, now here I'm calling this a method, not just a function. But the only difference between the two is that the method is embedded inside of, I hit the up arrow, inside of a class. So because I'm inside of class rational, this is inside the scope of the class, and that means that we're going to call it a method. It has automatic access to certain things. For example, it knows the numerator and the denominator here. Actually, how about we just start really simple. Print. And what the print is going to do is print numer over denom. Yeah. So actually, there are ways in which the REPL is not going to like me defining a case class followed by a class of the same name. Okay, so I've made this class rational, and I can instantiate objects of this type with new. One of the things that the case class did for us is it made it so that we didn't necessarily have to use new. We'll describe how it did that later on in this chapter. So I have a new rational object. It prints out in a way that might look a little bit odd to you. We will also learn how we can fix that a bit later on. But we did put a method called print inside of here. And so we can call that method print, and it operates, does what it's supposed to on this print. But notice we're using the method syntax. Okay, so this is the first time that we've added our own method into a class. And the thing about classes is these classes are, I really love the analogy of they are a blueprint. Okay, when I write this right here, this doesn't actually make an object that is rational. Instead, this says this is what goes into an object of the rational type, and when you call new, that's when you actually make a new rational. Okay, up until that point, you're not making a new object, you are just defining what objects of that type would look like. This is how we can add methods into here. Though I don't necessarily need it for the rational, in addition to putting a def for a method, you can add vals and vars inside of there. And actually, at this point, maybe we should jump out and actually put that class declaration over here. So class rational numer is an int, denom is an int. We're going to have a body inside of here, def print line numer plus a slash and the denom. That's not what I wanted. I don't want to VI it, I want to Scala it. Now, I'm not making this do anything. I would need to put something inside of the script where I create one of these and then tell it to print val r equals new rational 2, 3 r dot print. Okay, so that's very much like what we had before. At the very least, when we ran it, we could see that it worked. And here you can see it actually prints out a value. Now, what if I wanted to just print out the numerator? It's tempting to do the following. And then we attempt to run this, and you see we get an error. Value numer is not a member of this.rational. What that's saying is that the object R here, which is of class rational, the numer is not actually a data member. It's not something that we can get access to. And it turns out that when you pass things in by, now this would have worked perfectly fine if this was a case class. This is another one of the differences from being a case class. But in a normal class, if you want, so you can define your members either by doing something like this, where you have a val or a var that is inside of the class declaration and you give it a value. Or if you want these arguments to be visible on the outside, you can set them as either val or var, and they can each be different. And if we run this now, you can see this does what we wanted. So you can put, tell Scala that you want the arguments coming into a class. And so basically what a case class did is it made everything into a val. And so when you created a case class, you didn't have to say val, it automatically put it in there and made everything so that it was a visible val. And that allows the parameters to be methods. And that actually allows us to take our next step, which would be to write something like multiply. Now when I write multiply, I am inside of, so when you're in one of these methods, when you call print, remember print is it's a method, so it's being invoked on some object of type rational, like r.print. Okay, so the numer and the denom are just the ones associated with the current object. But when I call multiply, I'm going to multiply two different rational objects. So one of them is the one that's being called on, and the other one is the one that's being passed in. And so how about I call the other one R2? It's a rational, and the multiply method should return to us back a rational. Note that I have made my rational type immutable. One of the things, if your only data members are here in the argument list and they're all vowels, unless they happen to be vowels of mutable data, the entire class itself will be immutable. So a lot of times we will prefer to make things vowels over vars, as has generally been the case for Scala, so that we wind up with immutable objects. So how do you do rational multiplication? Well, part of the reason for choosing multiply instead of add or subtract is that multiply is actually the easy one here. When I take a and b, and they're two rational numbers, and I multiply them out, I get the new numerator is the numerator of the result is the product of the numerators, and the denominator of the result is the product of the denominators. So this becomes numer times, and then R2 dot numer, and denom times, I want that to be a comma, not a divide, R2 dot denom. Okay. So when I just use numer as it's shown here, I get the numerator of the current object, the one that we're being called on. There's actually a different syntax. You could say this dot numer. Implicitly, this is put there. In fact, that's why we got the error message that we had here. It said it's not a member of this dot rational. Here, we're pulling the numer out of a different object, the one that was passed in, the second argument, or the argument to multiply, as opposed to the thing that multiply is being called on. We can check real quick to see if this compiles. Error not found, value, denom. It would help if I could spell. And that compiles. And now we can do something like this, where we make another rational, val R2, equals new rational of 1/2. And then what I want to do is I want to multiply, and I'm actually going to use the operator syntax here. So R space multiply space R2 is the same as R dot multiply, and then in parentheses R2, then I want to call print on that whole thing. So I could also call it this way, and because that gives me a result, it will look like that. You can decide which one you like better, but indeed 1/2, 2/3 times 1/2 is 2/6, and so you can see that this works. So recapping, Scala is a class-based object-oriented language, which means that most of our objects are made by instantiating classes. The classes themselves are like blueprints. This bunch of code right here doesn't actually make any rational numbers. It just tells Scala what goes into making a rational number. And then when I call new, that's when I actually make a new rational number. So these classes are blueprints for building stuff later. And it's actually the blueprint that you write in your code so that it can be, at least inside of the main part of the class, and then elsewhere you can instantiate it and make new objects of this type. So that's your brief introduction. It's actually worth spending some time thinking of how you would represent some other types of objects as classes. What would they look like? What data members would they have? So what stuff would you pass in, or what vowels and bars would you need to declare inside of here? What methods do you have? Okay, what all goes into building it? You might spend some time just writing some different classes that represent, it could be a student in a class, a car, a house, whatever it is that you want to represent. Obviously, rational numbers and complex numbers make good examples. We'll learn more things about how we can handle those better in the coming videos as well. But play with this. Try representing some things. And the book has some exercises that will give you some ideas for things that you could go about creating data types for.